data collection experiment. We would employ two methods of drone data collection and then compare and contrast the results.
Here we have the Memorial Tower in the heart of LSU's campus, erected in 1923 and officially dedicated in 1926 to all of the veterans who died in World War I.
Normally, a drone flight path is actually directed from a horizontal perspective for the aerial view. For this project, we'll be utilizing a new software function with UGCS, which allows for vertical flight paths. These paths will allow us to develop an orthomosaic from a point cloud, which we will convert to a mesh and then a solid to make a 3D print of our structure of interest, the clock tower.
And that was the start of this project. We would use the new software to create a vertical drone flight plan around the LSU Memorial Tower and collect photographic data. Then create the typical horizontal drone flight plan and again collect photographic data. Next, process the photos through Agisoft Metashape and ArcGIS Pro to create a DSM, a DTM, and an orthomosaic. Finally, we would compare and contrast the two processes and end results for the joy and enlightenment of all.
These are some of the problems which we anticipated running into while collecting data. The people problem was avoided by using standard operating procedures for drones and having a dedicated watcher on the team. One side of the building was difficult to photograph because of intense GPS signal interference. And finally, we had to adjust our schedules a couple of times due to bad weather.
But life often does not go according to plans. Sometimes, surprises appear seemingly out of nowhere. So you take a few moments to reassess, you make a course correction, and you continue boldly forward.
Due to unforeseen circumstances, we were not able to have access to the UGCS software.
So we rerouted our project and decided to render the 3D model using manual vertical flight photos and a few other things. We flew the Paradanafi drone and took photos of each wall of the Memorial Tower and the connecting building, taking care to only take pictures vertically and not from a God's eye view looking down. The Agisoft Metashape software did not know which wall to connect to which, so we returned and took more photos, this time of the corners of the tower and the building. Using these photos and with a little work in Metashape, we were able to create a stable STL file, which was then used to 3D print two test models on a frozen Sonic Mighty 8K resin printer. Unfortunately, we did not have as good of luck in ArcGIS Pro using those same Metashape files. So we built a DSM, a DTM, and an orthomosaic from scratch in ArcGIS Pro. What you're looking at is the result. Even with the photos of the building corners, ArcGIS Pro added an extra side of the building and had holes in the rooftops and walls, which did not occur in the Metashape software. At this point, we've flown the drone a few times to get better photos, including a horizontal or God's eye view path, in an attempt to correct the problems we faced in ArcGIS Pro. The horizontal photos only made things worse, and with the addition of these new photos, the digital surface and terrain models, along with the orthomosaic, were flattened. However, we have shown that it is possible to build 3D models using only vertically taken photographs, and even found a couple of tips in making that process work better. How do we move forward on the project at this point? I dug up some old drone photographs of the LSU campus mounds and the Poverty Point mounds, which were from classes in 2019 that I took, and added them to this project. Here, we see the newly created models in ArcGIS Pro using those old photos of the LSU campus mounds. The orange-colored lines are the flight paths, and the yellow squares are the cameras, or rather where the cameras were when the photos were taken. These photos from 2019, or more accurately, these models created from those photos, can be compared to newer models and used to determine if any slumping or creep has occurred on the LSU mounds over these past several years. This is important now that the mounds are a protected archaeological site. The original photos were taken with the DJI Phantom 4 drone, a relatively expensive model. The newer photos, and all photos taken this year for the project, were with a $300 Parrot Anafi drone. The LSU mound photos were more of a horizontal flight path and from the God's eye view or looking down. The drone, the Anafi Parrot, was manually flown and photos were taken in about 15 minutes time. We now have two models of the LSU mounds at about 4 years apart, which we can now compare and use for future comparisons. Future work for this project includes taking a larger number of photos of both the LSU Memorial Tower and the campus mounds and seeing if that helps with the orthomosaic rendering from the Parrot Anafi. The largest differences between the older drone photos and these new ones are that the older photos were taken from around 100 meters above ground, while these newer photos were taken from 5 to 10 meters above ground, and the older photos were generated automatically from an automated flight path, while these new photos were manually taken from a drone being flown manually. Finally, we have models created of Poverty Point from drone photos taken back in 2019. These models were created along with all the other models in this project using this new ArcGIS Pro. The next step for Poverty Point would be to make a trip there to get new pictures and then create 3D models, DSM, DTM, orthomosaic, and compare these new ones to the ones we've created in this project from 2019. What follows are some quick instructions on creating digital surface models, digital terrain models, and orthomosaics from start to finish. Go to Imagery and click New Workspace. Fill in name. Accept most defaults. Base map, you can change topography to imagery if you like. Hit Next. Source, click Add and select Folder with your images. Hit Next. Hit Finish. Go to Ortho Mapping. Hit Adjust. Click Quick Adjust. Click Tie Point Matching. Choose Accuracy. Hit Run. Once finished, click Adjust again. To save the settings you just ran, run again. I didn't do any ground control points for this project, but we also didn't do them in 2019. It seemed to work fine with the drone a few years ago, so the conclusion was it would work this time also, even though it's a different drone. I didn't have to input any coordinate system because ArcGIS pulled the information from the drone's camera, and the buildings lined up with the pre-existing map, so it seems we're good on that aspect. Now we are off to the digital service model, or DSM, creation. Accept the defaults on the first page, hit Next, change format to TIFF format, hit Finish. ArcGIS tries to share the workload. At the bottom of the screen it reads, distributing operation across 8 parallel interfaces, which I'm guessing are the 8 cores on my laptop to make the processing flow smoother and quicker. Now we go to Digital Terrain Model, or DTM. Go ahead, click Next to get to the second screen. All we're going to change here is format to TIFF format, hit Finish, and wait for it to finish. Tap the orthomosaic button and we'll work on this part. Hit Next. Use the DEM you've created in the workspace already, or you could choose Use DEM Product and then pick either DSM or DTM. We'll take the defaults here and hit Next. Next again. Ensure the format is set to TIFF format and finish. Then we wait for the ortho to cook. Here we've converted the map to a local scene. We'll start with an up-close view of the base map. Then we'll add the DSM, then the DTM, and finally the orthomosaic. I want to point out the detail in the ortho. The drone was 100 meters above ground level for these photos, and look how great they look. It's kind of unbelievable. Now we're going to start removing things. We'll take off the ortho, the DTM, And finally, the DSM, just giving you a bird's eye view of the entire mounds here. Then we're going to add the blue lines for the footprint. And then the flight path and the cameras. And so after everything loads up here, we're going to zoom back in for a close-up view of the ortho once we click that back on. And what we're going to be looking at here is the little yellow boxes where all the cameras are. Now once this catches up, they'll spread out a little bit and such, but you're still going to see a tremendous amount of overlap. Now remember, when these pictures are being taken, the drone is 100 meters above ground level. And so y'all have been to the mountains probably and know how large this area is. Each of these drone pictures is, a meter, 2 meters away. It's not that far away. So there's a lot of overlap from 100 meters in the air. So now we're going to get a side view here just to get a better idea of what the mounds look like in the model itself. And so this will be a model we can use to compare year after year or decade after decade and figure out how much creep, how much slumping, how much the mounds are being degraded.
Where do we go with the project now that the semester's over? Well, first we want to take a larger set of photos, a larger number of photos of the LSU mounds and the LSU Memorial Tower. Secondly, we want to do a larger set of both of those places, but from around 100 meters up. Then we'll take both of these sets of photos of each place, the mounds and the clock tower, and we'll create a new digital service model, a DSM, a new digital terrain model, a DTM, an orthomosaic, and then we'll conduct a new drone survey of Poverty Point. We will take all these new sets of DSM, DTM, and orthomosaics from Poverty Point, the LSU campus mounds, and the LSU Memorial Tower, and compare these new ones to the old ones, and see if we have better new models than the ones we did in this project, and see how the new models of the Poverty Point mounds and the LSU mounds compared to the models from 2019, and see if we can detect any kind of creeping or slumping or changes. That about wraps up everything for this presentation.
If you have any questions,
If you have any questions,
If you have any questions,
feel free to ask.
feel free to ask.
feel free to ask.